Welcome you all to one more session in Frontiers in CFD. So today we are going to see the floating point exception error. When it occurs in CFD simulation, what to be done. So first of all, whatever the error has come, we'll visualize that. Second, we'll try to modify the mesh size. What will be the best mesh size for the given simulation, that will do. And we'll try to run the simulation whether we get the same error or not, and we'll check out. So after performing the iteration, we have received one error which is called as the floating point exception error. We'll just check it out what goes wrong. We'll check out the console, what is the things which is specified. So it says uh, the global Courant number is greater than 250. So this is a velocity field is probably diverging. Please check the solution and reduce the time step requirement if necessary. The global Courant number is greater than 250. Just check it out how much it has came. So we ran around 2000 time step, but this error has occurred, that is 5.69 10 to the power 9 over here. So probably we cannot proceed with the simulation even if somebody tries to do it calculation. Just see here, if I just try to click on it, it will give the same error, that is floating point exception error. So we cannot proceed with this the simulation. Even if you reduce the time step or something, it will not going to help us anyway. So what to be done in such situation is simply go back to your mesh and check out how the mesh size is. If you have seen the video which is related to Courant number, so in that case we are suggested select a suitable mesh size and select a suitable time step. So that thing we have to follow. So what I will do is I cannot proceed with the simulation any further. So what I need to do is I need to go back and change the mesh size, and this is the only possible way by which we can do. If somebody takes like I take 0.005 and try to do the calculation, again it will go on to give the same error uh, like the floating point exception error. So the same error will be obtained. So changing the time step size will not that help us. So we need to go back to mesh and change the mesh, and then we can start with the simulation. Similar kind of simulation I run on some different computer with some different uh, the mesh size. So it has run quite easily, but here it is giving the error. So what I will do is I will go back to my mesh and change the size of mesh, and will proceed with the simulation again. So what I will do over here is I'm going back to the mesh. Will open the mesh and I will change the element size. This is the possible option which we can do. Right now it is uh, standard default is 5.64. Okay, just check it out. Okay, 5.64 393 and 10 to the power minus 3. This is what I'm having. Now see, if you are trying to select the mesh size, how the things has to be remembered. This is now it is taken 0.0004. If I take 0.0005 and make it update, so earlier it was 288,831. Now just check it out how much it is. It is 269,209. So you can change mesh only when it is in the limits. Like if I try to take 0.0001, just check it out how it goes. Make it update. It is 269,201. Now just check it. It can take time depending on, because we are taking a very small mesh size, the element size. So we are using the student version, so it should be within the limit of 5,12,000 node. So if this value which is we are doing right now, if it is more than 500 to what we say 5,12,000 nodes, so in that case we have to reduce the element size. Probably this is taking too much time, so it means this is going to be a very fine mesh. This may not be suitable because of the student version of Ansys and has to be reduced. I will check it how it comes out. Definitely it is taking time. It means it will be a very fine mesh. Okay, so now it has been generated 631433. So this is quite big, not within the limited version. So I will take 0.0005 and we'll just try to generate it, generate the mesh. Now it is 2,69,000. We'll make it 0.0004. Just check it. Generate mesh. 2,88,831. You can take it to 0.0003. Sorry, 0003, and just check it out how it comes out. Generate mesh. So likewise, you can change the mesh. Now it is 3,51,014. Okay, so that is again a bigger value. 3,51,143. So this may not. This can be there, but the time required for simulation will be increased. So I will keep it 0.0005, and I will start with the simulation again. So whatever the boundary condition I had earlier, the same boundary condition I am going to use. We'll just go back to your workbench window over here. One thing which left is make it update. So the mesh translation to Fluent is successful. So when you go back to your uh, actually we don't want to change the setting, we want to keep the setting as it is. What I will do is I'll just want to initialize it again, and then we'll proceed with this. Okay. Object history has been deleted. Water volume fraction 1, patch with the water, make it close. And okay, so this is what we had done. Just running one more time. Let's see. So reload option has been done. One more time I will try to run this simulation again and just check it out how the things will proceed. Okay, sorry. First one, initialize, make it patch water volume fraction 1, make it patch, and then close it. Now go to the run calculation and run it again. Now the problem should not come as the earlier case. So again the problem has came. So what I will do is again go back to your workbench window. I will clear all generated data. I will close the Fluent option. here, don't save changes and exit. So see, clear generated data, and then I will go on to make it reset over here. So clear, make it clear. This is also need to be clear generated data. Okay, make it reset also. Yeah, now I will start with the whatever mesh size we have taken. Again we'll start with the simulation. Say for example 4, start. Earlier the error has came out on I guess 2000 number of time step, so around 3000 number of time steps. So we'll go on to proceed with this again, transient, then gravity, specify as per the requirement. Yeah, then you are having model multiphase, you need to make it on volume of fluid. You say implicit body force, make it apply, then close this, then energy equation is there, make it okay, this one, then K epsilon, enhance wall treatment, thermal effect, curvature correction, make it okay. Then go with your material, it is has to be selected from library, fluent database, just go with water liquid, copy, then close, change create and close this. Here you should select uh, copper, then Cu, this is 387.6, make it change create, yeah, and then close this. Now go to the cell zone condition, say water, we have it is 4000 pascals, make it okay. Then boundary conditions we are having. So before that I will just go with the multi-phase model. I will go on to change this phase to steam, so it is water vapor, make it apply. Secondary phase I will specify as a water, so specify the water liquid, make it apply. Then go to the phase interaction, constant 0.0736, surface tension model, then heat transfer mechanism, water, it has to be converted into steam, so evaporation condensation, specify this is to 303 Kelvin, make it okay, make it apply and close this. Okay, so don't need to worry about this one, this will be rectified. Now go back to your condenser, edit it to 20, make it apply, close this. Heater also you need to specify, say this is 20, but you need to specify temperature here, this is 343 Kelvin, yeah, make it apply and this close. Every wall condition you have to specify as a, this is a contact angle, that is 20, close this, this again 20, make it apply. Here also we are taking, this is 20, make it apply. This also we need to change. Okay, close this. This is 20. So last thing is left. We have tried this process again because we are not able to solve it because of the problem of the floating point exception error. So let's make it again 20 and then we'll proceed to the further section. Okay, so last is left, make it 20. Okay, this is how the things are done. Now you have to proceed further. So go to the initialization. Yeah, make it initialize. Then patch your zones. Water, volume fraction. This is 1. This is with the water. Patch and close this. Calculation activities. You can set this to say, for example, 20. Solution animation. This is say water, liquid. Okay, new object, contours I will select. I need phases, so volume fraction of steam I required. So select your wall region, go to color option, then select float, make it apply and close this. This one you can specify water, liquid, volume. Okay, make it save display, compute and close this. Sorry, one thing is, I guess, go to initialization again, initialize one more time, patch, this is one with water only. Okay, so just check it, this one. Okay, so we haven't made it water, so make it. Okay, so earlier it was showing the red above, so this is the error which we had done. Now we have corrected that. By mistake we have selected water, steam, so that's why it has came. Okay, now make it front and let's, you can specify this also, water, liquid, make it okay and just go with the run calculation. I will specify somewhere on adaptive time step, then save 500. Here I will take 0.0005 and I will start with the calculation. Earlier mesh size and this mesh size is quite different, so there is likely that the time required may be different than what we have seen earlier and what we are observing right now. So these are things which can happen. This is how we are trying to overcome the problem of the floating point exception error. We have to check it whether it gives us error or not, because we need to run this for some many number of iterations, then only we'll come to know whether it gives an error. So we'll stay updated. Last time it was the error come at 2000 number of time step. We'll check out whether this error comes again or not. So if you see now, it is around 1000 time step which has been completed. As of now we have not got any kind of error, but what was the difference in earlier simulation and this simulation is the fluid was trying to flow in this direction, now here it is over in this direction. So we'll just continue this the simulation for more number of time step, because last time it was the error comes at around 2000 time step. So we'll check it out whether this error comes out at next 2000 time step. So we'll run again for 500 time step and we'll check out and update you whether the error comes or not. If this error doesn't come, so it means whatever the mesh size we have selected, it is suitable as per our CFD simulation. So we are around 45,000 number of iterations and we already crossed 2000. We have seen in the earlier case where we have got the error at somewhere around 2000 time step, but actually we are already crossed here more than 2000 time step. So whatever the things which we have done, that is a mesh, we have changed the size of the mesh, that has really worked over here, and we haven't got the floating point exception error as of now. So this simulation has been running. I will just update you once all this simulation has been completed. If it is possible for you, you can just check it out. This the time step which is over here, it is moving too fast, but you can see the time step which is available is quite more than 2000. So that will go on to we see whatever the process we have followed, that will go on to help you if you are encountered in a problem where you are seeing the floating point exception error. So this way how it can be resolved. So we are around, the calculation is completed, it was 2500. So still we haven't received any floating point exception error, so that is work quite easily. I will just take say 10 number of iterations and will show you whether it is working properly or not. So this is 2500 time step we are each, but still we don't have any problem of Courant number. You can check it again, around 50,000 times 50,000 iterations we have performed, and it is working well without any kind of error. So this is how the things can be done. Like you change the mesh size. This is the best option to overcome the floating point exception error. Okay, so this is, yeah, you can just check it out. It is 2510. The flow time is 0.387. Then we'll see the value of core and physical. Okay, so this is 6.9629 and to the store minus 5 is there. Global current number is 0.37, so this is quite lower value. This is less than 1. So till the time this value is less than 1, you're going to will have the solution in the proper way. But if it goes more than, then could be the errors. But whatever the mesh size we have selected, it definitely will go on to run this simulation for a long time.